All right, let's talk MLOps. We all live and breathe Git, right? It's where our models are born, where they evolve. But once they get deployed, that crystal clear line of traceability can get a little fuzzy. Well, today we are going to fix that. We're going to build a direct bridge from your GitHub commit all the way to your production model monitoring using Whitebox AI.
So let's really think about this for a second. You can go in your repository right now and find the exact code for your model. Easy. But can you go into your monitoring dashboard and find the real-world performance data for that specific commit hash? Yeah, for most teams, that's a hard no. There's a huge disconnect, and that's exactly the problem we're here to solve today.
So here's our game plan. First, we're going to really define that disconnect and talk about the simple concept that bridges it. Then we'll get hands-on with two really powerful patterns to make it happen. One that's fully automated with GitHub Actions, and another for more manual tracking. After that, we'll see the incredible traceability this all unlocks. And finally, you'll get a little sneak peek at the future of this integration.
Okay, so first things first, let's really dig into the core challenge here. How do we connect the world of version control, our commits and branches, with the world of live, in the wild production inference?
Yeah, this is the gap we're all familiar with. In GitHub, you know with absolute certainty the state of your code at commit ABC123D. But then you look at your monitoring tool and you just see metrics for something generic like production model V2. But what if V2 has had 3 hot fixes pushed since then? How do you trace a sudden dip in accuracy back to one specific code change? That's the traceability we're all missing.
Now, just to be super transparent, Whitebox AI doesn't have a one-click install from the marketplace GitHub app yet. But hey, that doesn't mean we're stuck. The solution's already here, baked right into the SDK. We don't have to wait for a new feature. We can use these really powerful existing patterns to pass Git metadata directly and effectively link our deployed models back to the exact commit they came from.
And this brings us to the core concept, what I like to call the metadata bridge. And you're going to love how simple this is. The Whitebox AI SDK has this super flexible metadata field. We're just going to use that field as a bridge to pass crucial Git info, like the commit hash, the branch name, directly into the platform. This one simple idea, it's the key to everything else we're about to do.
All right, enough theory. Let's get practical. Our first pattern is for all you teams out there that love automation. We're going to use GitHub Actions to create a totally seamless CI/CD workflow that handles all of this for us automatically. So, what's the goal with this first pattern? It's simple, but man, is it powerful. Every single time a change gets pushed to your main branch, we want to automatically register a new, perfectly versioned model in Whitebox AI. No manual steps, no thinking about it, just pure, automated MLOps goodness.
And take a look at this. The coolest part is how little code it actually takes to get this done. This is just a standard GitHub Actions workflow file. It checks out the code, and then it runs a tiny Python script. The real magic, though, is in those variables it uses, which GitHub just gives us for free.
The power here comes from just a few key variables. The whole thing kicks off on a push to main. It securely grabs your API key from GitHub secrets, which is great. Then, it uses github.repository as the model's name. Super convenient. But the real magic, the absolute star of the show, is github.sha. It grabs the full, unique commit hash from the push and uses that as the model version in Whitebox AI. And just like that, every model version is now permanently tied to an exact commit.
Okay, that's the automated way. But what if you're not using GitHub Actions? Or maybe you just want more control when you're developing locally? Well, you can get the exact same result directly in your Python code. Let's look at that pattern.
Here, the idea is basically to get our Python script to ask Git, hey, what's the current commit hash and what branch am I on? And then just pass that information right into that metadata field when we register our model. This is absolutely perfect for experimentation or when you're just running a training script on your own machine.
So check out this Python script. It's using Python's built-in subprocess library to run commands just like you would in your terminal. We're running 2 simple git commands to grab the current hash and the branch name. Then we just pass those variables directly into the register model call, using the short hash as the version and tucking the full details right into the metadata.
So how does this work? Step by step. It's really simple. 1. We import subprocess. 2. We run git rev parse head. That's the standard way to get the full commit hash. 3. The command gives us back bytes, so we just decode it into a normal Python string.
And finally, step 4, we just pop those strings right into the metadata dictionary. It's clean, it's simple, and it gives you complete control.
Okay, so we've seen how to do it. We've got 2 solid patterns. But now, for the fun part, the why. Why even bother with all this? What does this integration actually give us? This, my friends, is where it all comes together.
Right away, your model registry becomes 1,000 times more useful. Instead of some ambiguous version number like 1.2.1, your version is literally ABC123D. You can immediately copy that, go to your terminal, type git show ABC123D, and see the exact code that produced that exact model. The link is direct, it's unmistakable, it's perfect.
And this is the holy grail right here. Imagine seeing this in your Whitebox AI dashboard. Every single prediction your model makes in production is now stamped with the exact commit hash of the model that made it. See that slight performance dip between commit F456GH78 and ABC123D? You now have your prime suspect. You can instantly go and investigate the code changes between just those 2 commits. This is true end-to-end traceability. And look, this isn't just some neat trick for engineers. This brings huge value across the entire team. Data scientists can finally connect what they did in an experiment to what's happening in reality. MLOps engineers get cleaner pipelines and way better governance. And for your compliance teams, this is an absolute dream come true. A perfect, unbreakable audit trail from a single line of code all the way to a live prediction.
So what we've just walked through is super powerful and something you can do right now. But believe it or not, this is just the beginning. Let's take a quick look at where this integration is going next.
The official roadmap shows a really clear path to an even deeper integration. It'll start with basic connections, then move to automated tracking with webhooks and config files, and then it gets really cool with advanced analysis, like automatically diffing model architectures between commits right in the UI. The final phase, of course, is that full native GitHub app to make this whole process completely seamless.
So, when you boil it all down, what have we done here? By putting these simple patterns in place, you're not just organizing your models better, you are transforming every single commit into a verifiable, traceable, and auditable part of your production system. The question is no longer which code produced this result. With that question finally answered, the real question is, what will you build next?